Good afternoon. We're Group 13, and our project is called the e-skate, which stands for Electric Skateboard. My name is Cesar Romero, this is Camilo Romero, and this is Oscar Cedillo. The goals and objectives is to create a skateboard with simple user feedback, create a fast transportation method inside a college campus. User will control the e-skate by a wireless controller. It's going to be portable and easy to charge, and it's going to be low cost. For example, here at the University of Central Florida, sometimes in engineering we have some classes on the economics field, communications building. So we have to travel far distances. So that's why we decided to create the escape. The project description, eso no tiene pensé que borrar. Specifications. It's gonna cost around 500. We have a $500 budget for the project. It's gonna be under 15 pounds. It's gonna have a 3-hour battery life, 10 feet range for wireless communication, cruising in clear weather conditions, 12 volts battery system, which has 5 amps per battery, and 100 watts DC motor. The design is gonna consist of 3 separate parts. The first part is gonna be wireless control, then it's gonna be the data control and the motor control. The wireless control.
No, don't play that.
Yeah, sorry. Esto lo digo mucho, ya me doy cuenta. The microprocessor that we're going to use is the ATmega 328P from Atmel. It has 2 kilobytes flash memory, max operating frequency of 20 megahertz, 23 I/O pins, serial communications, SPI, IRS-232, and I2C. The operating voltage is from 1.8 to 5.5 volts. It has 6.6 channels, 10-bit analog to digital converters. We decided this is a really good microcontroller for us because it has lots of I/Os which we can connect to our devices. In order to program the board, we're gonna need an Arduino development. In order to program the microcontroller, we're going to need an Arduino development board. The one that we acquire is the Arduino Uno, which has a 5 volts operating voltage, 7 to 12 volts input, 14 digital I/Os, 6 channel 10-bit ADCs. It has a 16 megahertz clock speed and is programmed with the Arduino software, which is really similar to C++. The wireless control part, it's gonna consist of the ATmega 328 chip, a potentiometer for speed control, and transmitter, which is gonna transmit wireless data to a receiver on the board itself. The transmitter that we're going to have, it's WRL 8945 from RF Link. It has functions in the 315 megahertz frequency. It has a 500 foot range, and it could work either in 2400 bps or 4800 bps. It's really low cost and really small and lightweight. The operational voltage is from 1.5 to 12 volts, and its operational temperature is around from -20 degrees C to 85 degrees C. As well, the receiver is going to be from RF Link, and it's going to be WRL 10533. Also operates in the same frequency. We needed to operate the same frequency so they can communicate correctly. They function in the amplitude shift keying modulation at a rate of 4800 bps. And the supply voltage, we need to turn it on, it's 5 volts as well. The user is going to need a hands-on remote control. So we decided to get this remote control from which one of us donated for this project. The remote control is going to have a on and off switch, the signal switch, and it's going to have the 80 mega transmitter and potentiometer right there, and a 9 volts battery to power the electronics. The following slide shows the connection to the transmitter and the microcontroller. You can see the microcontroller has all the power connections right there, and the transmitter only needs power, ground, and a data in connection. To the right, you can see we tested it on the Senior Design Lab. As well as the transmitter, the receiver has the similar connections. It's going to have the ground, data in, power, pipe bolts, and also an antenna. Right now, we're gonna have to pass it to Oscar, who's gonna talk about data control.
Well, I'm going to talk mainly about the GPS módulo.
No, puedes decir primero, like, todo lo que está ahí.
Okay, yeah. Now I'm going to pass to Oscar. Hey, how are you? I'm Oscar. I'm going to talk about the data control a little bit. My main part is going to be the GPS, but the data control is going to have the pirate sensors, the accelerometer, the motor encoder, and the LCD. All these are going to be integrated to the microcontroller, and it will be output to the LCD to show the data. The GPS model is very small, as you can see. It's very small and very light. And the GPS name is the EM406A module. Module. This GPS specs have 20 channels, receiver.
How you doing?
Okay.
Do you wanna, hi, do you wanna, ¿cómo están?
Buenas.
Miren, tómense un juguito.
Muchas gracias.
Perdonen.
No sé, era que
No,
se
estoy-
confunde.